The mathematics of probability. We are going to review ratios, proportions, decimals, approximation, percent, and language. A ratio is an ordered pair of numbers A to B that is used to describe a relationship between two quantities. In primary school, class size is limited to 20 students. That is, there are 20 students to one teacher. There is a 20-to-1 ratio. This bar graph represents the students to teacher ratio. On the left, a bar of length 20 represents students, and on the right, a bar of length 1 represents the teacher. In this class, there are also 12 girls to 8 boys for a total of 20 students. The ratio is 12 to 8. The bar on the left represents the 12 girls. The bar on the right represents the 8 boys. There are also 12 girls to the 1 teacher. The ratio is 12 to 1. The left bar represents the 12 girls, while the right bar represents the 1 teacher. There is 1 teacher to 8 boys. The ratio is 1 to 8. On the left is the 1 teacher, and on the right is the 8 boys. We express ratios as fractions. A to B becomes A over B. This is very helpful in performing calculations. The 20 students to 1 teacher becomes 20 divided by 1 as a fraction, where 20 is the numerator and 1 is the denominator. There are 12 girls to 8 boys. The 12 to 8 ratio becomes 12 divided by 8. There are 12 girls to 1 teacher. The ratio of 12 to 1 becomes 12 divided by 1. There is 1 teacher to 8 boys. The ratio of 1 to 8 becomes 1 over 8. A proportion is equal ratios. The ratio on the left of A to B, represented as a fraction A over B, is equal to the ratio on the right of C to D, represented as C divided by D. This is a proportion, and they're very useful in performing calculations. Grandma's cookie recipe requires 3 eggs for every 2 tablespoons of sugar to produce a dozen cookies. That's 12 cookies. If you're in need of 50 cookies for your daughter's back-to-school night, how many eggs and tablespoons of sugar are required to use Grandma's cookie recipe? Grandma's cookie recipe calls for 3 eggs to 2 tablespoons of sugar, which generates 12 cookies. If we let x represent the unknown quantity of eggs, y represent the unknown quantity of sugar, for 50 cookies, we can create a proportion that relates the 3 eggs to 12 cookies equal to x eggs to 50 cookies. A second proportion relating the 2 tablespoons of sugar to 12 cookies equal to the y tablespoons of sugar to 50 cookies. We solve for x, solve for y. We'll determine the amount of eggs required, the amount of sugar required for 50 cookies. Three to 12 is x to 50. Multiply both sides by 50. Using algebra, we get x equals 150 divided by 12. This is the amount of eggs. Numerically, 150 divided by 12 is 12.5. In other words, we're going to need 12.5 eggs for 50 cookies. The 2 tablespoons of sugar to 12 cookies is some y tablespoon of sugar to 50 cookies. Multiplying both sides by 50, using algebra, we get y is 100 divided by 12. This is the number of tablespoons of sugar required for 50 cookies. In other words, there's 8.3333333 tablespoons of sugar required for 50 cookies. If we approximate this number to the nearest tenth, it's the first 3. The second 3 says to leave the first 3 alone. Remember, the digit to the right, if it's a 0, 1, 2, 3, or 4, in this case it's a 3, means leave that 10th digit, the 3, alone. The answer is 8.3. .3 tablespoons of sugar are required for 50 cookies. If you earn $534.55 in 5 working days, how much would you earn in 28 working days or in 3 working days? I'm going to create the ratio of $534.55 to 5 days, the ratio of x dollars to 28 days, and another ratio of y dollars to 3 days, where x is the amount of money earned in 28 days and y is the amount of money earned in 3 days. These ratios are going to be used to create proportions in which we can determine the value of x and y. The first proportion of $534.55 to 5 days equals some x dollars to 28 days. If I multiply both sides by 28 and use algebra, x equals 28 times $534.55 divided by 5. In 5 days, at the rate of $534.55, one would earn $2,993.48 in 28 days. Using the $534.55 to 5 days equal to y dollars in 3 days, we create a proportion in which we multiply both sides by 3. Using algebra, we find that y equals 3 times $534.55 divided by 5. $320.73 is earned in 3 days. Approximation. This is a portion of the place value system. The decimal in the center separates two different regions. On the left, the first space is the ones position, the next is the tens, and then the hundreds. This isn't limited, it goes on forever. To the right of the decimal, the first space represents the tenths position. The second space represents the hundredths position, and the third space represents the thousandths position. This also goes on forever. It is just a portion of the place value system. Consider the number 123.4564. If we want to approximate this number to the nearest thousandths, we locate the digit to the right of the decimal that's in the thousandths position. This 4 is in the tenths, 5 is in the hundredths, the 6 is in the thousandths position. We look at the digit to the right. If that digit is a 0, 1, 2, 3, or 4, like in this example it's a 4, the approximation will be 123.456. That is, we leave the digit in the thousands position, the 6, alone. This number is approximated to the nearest thousandths. Consider the same number, 123.4564. If we want to approximate this digit to the nearest hundredths position, well, we look to the digit to the right of the decimal that's in the hundredth position. The 4 is in the tenths, the 5 is in the hundredths. If we look at the digit to the right of the 5, recall that if it's a 0, 1, 2, 3, or 4, we leave the 5 alone. In this case, it's a 6. If the digit to the right of the digit in the hundredths position is a 5, 6, 7, 8, or 9, what we do when we approximate the answer is we add 1 to the 5 and make it a 6. This number, 123.46, is approximated to the nearest hundredths position. We simply add 1. When we consider the number 123.4564, and we want to approximate this number to the nearest tenths position, we locate the digit to the right of the decimal that's in the tenths position, and in this case it's the 4. The digit to the right is a 5. That means the approximate value is 123.5 because we add 1 to the 4. The digit to the right being a 5, 6, 7, 8, or 9 indicates that we add 1 to the 4. If we consider again the same number and we want to approximate to the nearest whole number, we simply look at the first digit that makes it a whole number. In this case, it's a 3. To the right of that digit is a 4, meaning we leave the 3 alone. If the digit to the right is a 0, 1, 2, 3, or 4, we leave the digit alone. 123 is the approximate value to the nearest whole number. Or simply divide by 100. I have the definition here of triangle percent being equal to triangle divided by 100. Let's apply the definition of percent to 2%. That's 2 divided by 100. 2% is 0.02 numerically. We represent 2% by the value 0.02. Let's apply the definition of percent to 13.5%. That's 13.5 divided by 100. (13.5%) is represented as 0.135 numerically. (13.5%) is 0.135. Let's apply the definition of percent to 128%. That's 128 divided by 100. (128%) is 1.28 numerically. (128% is 1.28. Let's apply the definition of percent to 0.75%. That is 0.75 divided by 100 is 0.0075. That is 0.75%, which is less than 1%, is 0.0075 numerically. 5% is 0.05. 8% is 0.08. 2% is 0.02. 10% is 0.1. 18% is 0.18. 22.5% is 0.225. 128% is 1.28. And 10.2% is 0.102. Notice the relationship between decimals and percents. 22.5% numerically is 0.225. The decimal moved 2 spaces to the left when you converted from percent to its numerical value. 128% is 1.28. The decimal moved 2 spaces to the left. 63% is 0.63. The decimal moved 2 spaces to the left. In order to convert a decimal to a percent, working backwards, we multiply the decimal this time by 100. 0.225 times 100 becomes 22.5%. 0.63 times 100 is 63%. 1.28 times 100 is 128%. The decimal this time moved 2 spaces to the right when we multiply by 100. Applying our percent relationship backwards, we take the numerical value of 0.02 and we multiply by 100. We get the 2%. That is, the numerical value of 0.02 represents 2%. If we look at the numerical relationship of 0.15 and we multiply by 100, we get 15%. That is, 0.15 numerically represents 15%. If we look at the numerical relationship of 0.634 and we multiply by 100, we get 63.4%. That is, 0.634 numerically represents 63.4%. If we look at the numerical relationship of 1.28 and we multiply by 100, we get 128%. That is, the numerical value of 1.28 represents 128%. This is working backwards. If there are 12 girls and 8 boys in a classroom of 20 students, what percent of the class are girls? 12 girls out of 20 students is 0.6. Multiplying 0.6 by 100 is 60%. 60% of the class consists of girls. If there are 12 girls and 8 boys in a classroom of 20 students, what percent of the class are boys? Eight boys out of 20 students is 0.4. Multiplying this number by 100 gives us 40%. 40% of the class consists of boys. This table represents the mortality rate of passengers who boarded the Titanic. We're going to learn how to read this table. Notice the first row is labeled survived. The second row is labeled died. The first column is labeled men. The second column is labeled women. The third is labeled boys, and the fourth is labeled girls. Various sexes and age groups of sexes, women, girls, men, boys, both survived and died. This table represents the number of which occurred. 332 men survived. 318 women survived. 29 boys survived. 27 girls survived. There were 706 survivors aboard the Titanic. 1,360 men died. 104 women died. 35 boys died. 18 girls died. 1,517 passengers died. If you take the 706 and the 1,517 added together, reveals that 2,223 passengers were aboard the Titanic. We're going to look at the columns now. 332 men survived. 1,360 died. 1,692 men were aboard the Titanic. 318 women that survived, combined with the 104 women that died, indicate that 422 women were aboard the Titanic. The 29 boys who survived, with the 35 boys who died, add up to 64 boys aboard the Titanic. The 27 girls that survived, the 18 that died, add up to 45 girls aboard the Titanic. If you take 1,692 added with 422 and 64 and 45, again, you get 2,223 passengers aboard the Titanic. What percent of the passengers died? (1,517) died out of the 2,223 passengers. 1,517 passengers died aboard the Titanic out of 2,223 passengers. If we approximate this number to the nearest thousandths, the 2 is in the thousands position and the digit to the right is a 4, which means our final answer is 0.682. Multiplying this number by 100 simply moves this decimal 2 spaces to the right. .2% of the passengers died on the Titanic. What percent of the passengers survived? 706 passengers survived out of the 2,223 passengers. .706 passengers survived out of 2,223 passengers. The 7 is in the thousands position. Looking at the digit to the right, being a 5, means to add 1 to the 7 to make our final answer 0.318. Multiplying this number by 100 simply moves our decimal 2 spaces to the right, meaning 31.8% of the passengers aboard the Titanic survived. What percent of the passengers were men? 1,692 men were aboard the Titanic out of 2,223 passengers. There was 1,692 men aboard the Titanic out of 2,223 passengers. If I look at this first one that's in the thousands position and look to the digit to the right, our final answer will be 0.761, approximated to the nearest thousandths. Multiplying this number by 100 simply means to move the decimal 2 spaces to the right. .1% of the passengers aboard the Titanic were men. What percent of the passengers were boys? There were 64 boys aboard the Titanic out of 2,223 passengers. There were 64 boys aboard the Titanic out of 2,223 passengers. The 8 is in the thousands position, but the digit to the right being a 7 means to add 1 to the 8 for a final answer of 0.029. Multiplying this number by 100 simply means to move the decimal 2 spaces to the right. 92.9% of the passengers aboard the Titanic were boys. What percent of the passengers were male? There's 64 boys, 1,692 men, both of which are male, out of the 2,223 passengers. 1,692 males, 1,692 men plus 64 boys divided by the 2,223 passengers. There were 1,756 males aboard the Titanic. This first 9 is in the thousands position. The digit to the right is a 9, which means add 1 to the first 9. The final answer approximated to the nearest thousands will be 0.790 because 1 plus 89 is 90. 0.790. Multiplying this number by 100 simply moves the decimal 2 spaces to the right. "79% of the passengers aboard the Titanic were male." What percent of the passengers were men who died? "1,360 men died aboard the Titanic out of the 2,223 passengers." "1,360 men died out of 2,223 passengers." Approximating this number to the nearest thousandths, I look at the second 1. The 7 to the right means to add 1 to 1 for an answer of 0.612. Multiplying this number by 100 simply moves the decimal 2 spaces to the right. "61.2% of the passengers were men who also died." What percent of the passengers were boys who died? There were 35 boys who died out of the 2,223 passengers. 35 boys died out of 2,223 passengers. The 5 is in the thousands position. Looking at the 7 to the right means to add 1 to the 5 for an answer of 0.016. Multiplying this number by 100 simply means the decimal moves 2 spaces to the right. "1.6% of the passengers were boys who also died." What percent of the passengers were males who died? The 1,360 men who died combined with the 35 boys who died out of the 2,223 passengers. "1,360 men died, 35 boys died out of the 2,223 passengers." "1,395 males died." If I approximate this answer to the nearest thousandths, the 7 is in the thousandths position. That 5 means to add 1 to 7 for an answer of 0.628. Multiplying this number by 100 simply moves decimal 2 spaces to the right, or 62.8% of the passengers were males who also died. I recently asked my evening statistics class how many children they had. This is a list of data I collected. There were many zeros, some ones, some twos, and few threes. The zeros represented no children as answers. The ones represented one child as answers. The 2 represented 2 children, and the 3 represented 3 as answers. It was difficult to make any sense of this sort of data, so I decided to organize my data into a frequency table. How frequent did each data value show up? The data value 0 represents no children, in which 30 students answered no children. The data value 1 represents the number of people that had one. 8 students had one child. The data value 2 represents 2 children, so 6 students had 2 children. The data value 3 represents 3 children, so 4 students answered that they had 3 children. This is a histogram representing the data that I collected. Notice that 30 students, as a bar, had no children. 8 students at a bar had 1. 6 had 2, and 4 had 3. How many students were in the class? Adding the frequency, the 30 students that answered 0, the 8 that answered 1, and the 6 that answered 2, combined with the 4 that answered 3, gives us 48 answers, representing 48 students. The total number of data values labeled by the value n is the sum of the frequencies. We can always determine from a frequency table how much data was collected by simply adding the frequencies. Being a good student in probability and statistics requires one to have some fundamental language skills. Language is very important. What percent of the class has no children? No children means 0 children. "30 students out of the 48 have no children." This answer is already approximated to the nearest thousandths position, 0.625. Multiplying this number by 100 moves the decimal place 2 spaces to the right. 62.5% of the class has no children. What percent of the class has one child? Eight students out of the 48 students have one child. Approximating this number to the nearest thousandths means that this third 6 makes the second 6 a 7. The answer is 0.167. Multiplying this number by 100 simply moves the decimal 2 spaces to the right. 16.7% of the class has one child. What percent of the class has 2 children? Six students out of 48 have 2 children. This answer is already approximated to the nearest thousandths. Multiplying this number by 100 moves the decimal 2 spaces to the right. 12.5% of the class has exactly 2 children. What percent of the class has 3 children? Four students out of 48 have 3 children. The first 3 is in the thousandths position. The 3 to the right of it means we leave this 3 alone. The answer is 0.083. Multiplying this number by 100 moves the decimal to the right 2 spaces. 8.3% of the class has exactly 3 children. This table is a percentage table. 62.5% of the class have 0 children. 16.7% has exactly 1 child. 12.5% has 2 children, and 8.3% have 3 children. What percent of the class has at least 1 child? At least 1 means 1 or more. The 1 is at least 1. The 2 is at least 1. And the 3 is at least 1. So if you had 1 or 2 or 3 children, you have at least 1 child. Take the 16.7, 12.5, 8.3, and add these percentages. $16.7 plus 12.5 plus 8.3. It's 37.5. .5% of the class has at least 1 child. What percent of the class has at least 2 children? At least 2 means 2 or more. The 2 is at least 2, and the 3 is at least 2. So if you had 2 or 3 children, you had at least 2 children. Take the 12.5 and the 8.3 and add these percentages. $16.7 plus 12.5 plus 8.3. $12.5 plus 8.3 20.8. .8% of the class has at least 2 children. What percent of the class has less than 1 child? Less than 1. Less than 1 means smaller than 1. The only data value that is smaller than 1 is 0. 62.5% of the class. .5% of the class has less than 1 child. What percent of the class has less than 2 children? Less than 2 means smaller than 2. 0 is smaller than 2. 1 is smaller than 2. So 62.5% plus 16.7% is the answer. $62.5 plus 16.7 79.2. 79.2% of the class has less than 2 children. What percent of the class has less than 3 children? Less than 3. Less than 3 means smaller than 3. 0 is smaller than 3, 1 is smaller than 3, and 2 is smaller than 3. So if we take the 62.5 with the 16.7 and the 12.5 and we add these percentages, we'll get the answer. 62.5 plus 16.7 plus 12.5. 91.7. 91.7% of the class has less than 3 children. What percent of the class has between 1 and 3 children? 1 is between 1 and 3, 2 is between 1 and 3, and 3 is between 1 and 3. The language of being between 1 and 3 includes the 1 and the 3. The 16.7 added to the 12.5 added to 8.3 will be our answer. 16.7 plus 12.5 plus 8.3. 37.5. 37.5% of the class has between 1 and 3 children. What percent of the class has no more than 1 child? No more than 1 is short for not more than 1. 1 is the limit. Zero is not more than 1. 1 is not more than 1. It's exactly 1. So 62.5 and 16.7 when added will be our answer. 62.5 plus 16.7 79.2. 79.2% of the class has no more than 1 child. What percent of the class has no more than 2 children? No more than 2 is short for not more than 2. 2 is the limit. Zero is not more than 2. 1 is not more than 2. And 2 is not more than 2. The 62.5, the 16.7 added with 12.5 will be our answer. $62.5 plus 16.7 plus 12.5. $91.7. (91.7% of the class has no more than 2 children.